Hi, here we are having our data in long format for the paired t-test that we used before, which we're considering as a repeated measure, which they are. And what we're going to do now is draw some graphs of this data. And an appropriate type of graph is what's known as a profile graph or a spaghetti graph. Basically, it shows the individual responses over time. So, we go to Graphs, Legacy Dialogues, Scatter dot. Simple scatter, define. Then once there we choose the result as our y-axis, our x-axis is time, as I say, and we want to divide up our data by each individual ID. Click OK, and here is our result. It's not very satisfactory, and in my notes that accompany this YouTube video I say why. For something that should be quite simple, it seems to be a real faff in SPSS, and it's much easier in R, which you'll see next. So in SPSS we've got a set of pre-scores on the left and post-scores on the right. We want to join them up. Well, that's not really possible without faffing on a lot. So let's see how we do that. First of all, we open up the chart by double-clicking it. Once we've got the chart editor window up, we choose this option that says fit line at subgroups, add fit line at subgroups. Click on that. Then we're offered a set of options, and we want the linear one, which is already chosen for us. So what it's now is done is produced a set of linear regression lines, and because there's only 2 points, the linear regression line will go through both points. So rather a lot of faff for creating something where we wanted just the lines to join up. We've also got all this gumph here at the side, which we can click on and delete. And now what we'd like to do is actually change this x-axis, because it doesn't make any sense. We only want to see time 1 and time 2 really there. So if we click on the time axis, then click on scale, and we notice that we've got here where it says major increment 0.2, change that to 1, say apply, and now we've just got the 1 and 2 at the bottom. And that's about as much as you can do in SPSS without learning the syntax for the charts as well. Not very satisfactory. So if you want to produce actually good graphs in SPSS containing longitudinal or repeated measures, you actually need to use the SPSS syntax, which I'm not going to talk about here. There's an excellent book on longitudinal data analysis written by Singer and Willett in 2002, published by Oxford University Press. Well worth a read, but along with that there's lots of examples of charts and graphs, a whole chapters devoted to them. And the website there at UCLA has actually put the code to produce all these graphs in not only SPSS syntax but also R, so you can compare them. First of all, we load our SPSS file into R. I'm going to do it the easy way using R Commander. So we use our library R Commander to begin with to bring up the R Commander window. R Commander window, we load our SPSS file, data, import data, SPSS dataset. We call it my data. And we don't want to convert the value labels to factor levels. Click OK. Then we find our data file. Once we've loaded our data, we just check by click View Dataset, and there we are, is the ID, the patients, the time, and the observation result. You can also check and make sure you've got the names correct by typing into the script window names, and then the name of the dataset, which was my data, and then press Submit, and there we are, names, ID, time, and result. We want to run a particular type of graph which is in a library called lattice, so we've got to load the lattice library. So just as we did with our command, we can do it within this window or within R. We type library, highlight it and submit it. You won't see anything, it just has loaded the library. Obviously I'd installed that library into R before, downloaded the code. If you look at my introduction to R, you'll see how to install libraries. We've just loaded it there. Now, to actually produce the graph we want, a profile graph, we type in one line of code, and it's XY plot bracket open, and we want to say result modeled by time, and we'll say we want actually our data to be grouped by patient, and we want to see both the values and lines between them, so we just use this both equals B. So the type of graph we want the lines plus the dots at the end of each one, and we use the letter B to represent that. And we haven't actually attached our data frame, so we've got to tell where our variables come from. So we say data equals my data. Highlight it and press submit. And then in the actual R window, there's our graph, exactly what we wanted. Obviously it can be extended, so we have more time points or we have more individuals. And I ask you to do an exercise when we've got 170 individuals and 4 time points. We can also add embellishments to this graph, just as we would do normally in R. I'll just give you a quick demonstration of that. I've typed in here the X command again, XY plot, and we've got result tilde time, and we've got group ID again, and the type we want the endpoints and the lines, and we said the same data set. Now I've added a Y label, number of curls, an X axis label before dash after, a heading to the graph, result from experiment X, and I've said change my X axis values, the scale, to actually equal 1 and 2 only. So if we highlight all that and click submit and go and look here now, it's changed. We've got a new title, new X and Y labels, and a change in the scale at the bottom. There's other things we can do as well. There's an interesting parameter called alpha, which is the degree of transparency. So if we set it alpha at 0.5, the number of more the lines would intersect with one another, the darker it would get. So if you say had 170 of these, you could actually make it so you could see the places where most points occurred and got less dark where fewer points. That's about it really. You just need to play now. Bye.